Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. Today in this lecture, we'll be learning about an important topic in binary search called upper bound and lower bound. What is this? Let's understand. Let's say, so here you are given an array. Let's say you are given an array. Okay. Now in this array, you can see some elements are repeated 5 times, 3 times, 2 times, right? Now let's say you are given a target. Okay. Now given a target element, let's say 2. Now, what a lower bounds mean? Lower bound mean the smallest index where a target value can be inserted. Let's say I want to insert 2 at the lowest index. What it could be? Lower bound means so where the 2 occurs for the first time. This is called lower bound. So here lower bound will be 1. So if we indexing it 0, 1, 2, 3, 4, 5 like this. So lower bound for this target will be 1. So lower bound for this two lower bound would be index 1. Okay, now what is the upper bound? Let's say I want to insert an element just greater than 2. What is that? This is 3, right? 3. Now if I want to insert 3 so that the order of the element are remain constant, then what that index would be? We can't insert 3 here, right? Because if I insert, so this is sorted, I can't insert it. So only position I can insert 3 is this, right? Insert 3 is this. So this would be my upper bound for 2. So for 2, the upper bound will be which element? Index 6. Index 6. Now let's say a different target. Let's say the target is 10. Okay, let's say target is 10. Now for 10, what is the lower bound? Lower bound means let's say I want to insert 10. So what is the lowest index that I can insert 10? So is there any 10 in this array? No, right? Then for 10, for this 10, lower bound will be what is the here, right here. So let's say the length of the array is let's say 12. Okay, let's say 12. Then then lower bound for 10 will be 12, because this is index 11, this is index 11, then this is index 12, right? That is imaginary, right? So for 10 lower bound will be 12. So if the element is not present, that means and it is higher than the last value, that means the index would be the last imaginary index, right? Length of the array. So for 10 also, what will be the upper bound? What will be the upper bound? Upper bound will also be 12. Because let's say what is the next element? Next element is 11, right? Now if I want to insert 11, in which index I can insert here? This is also 12, right? This is also 12, the last index. Because here only, so there is no 10 given, right? So if a element is not present, then what will be the upper bound? The upper bound will be the last index, right? I hope you have understood. Now let's take a different example. Let's take 5. Okay, let's take target element is 5. Let's say a different color. Okay, now this time target, let's remove all the things. Okay, now let's say this time target is equals to 5. Now for 5, what is the lower bound? What is the lower bound? Or 5, what is the upper bound? Okay, for 5, what is this index? 6, 7, 8, 9, 10, 11, right? So 5 is presented at 11. Okay, now what will be the lower bound? So if I want to insert 5 here in this array, so what is the minimum index I can insert? That is itself 11, right? So for 5, lower bound will be 11. For 5, what will be the upper bound? So let's say I want to insert element just greater than 5. What is this element? That will be 6. And for this 5, what will be the upper bound? Just next to it. That means 12. 12 will be upper bound, right? I hope now you have understood what is basically upper bound and what is lower bound. Now let's see how we can do this. So previously we have seen how we can find we can search for an element, right? In binary search, what we are doing, so we are just taking two pointers, low and high. Then we are doing this until low is less than equals to high. Then we are just finding a middle node. Then if the array of middle is less than our target element, then what we are doing, that means So this if array of m is less than target element, right? That means we have to move our pointer to the right. We have to search in the right side, right? So for that we are incrementing the pointer, right? Shifting the low to mid plus one. And otherwise we are just else if it is greater than k, that means we have to search in the left hand side, right? So we are just shifting h by m minus 1. Otherwise we are returning true, right? That we are doing here. Now to find upper bound and lower bound, we'll be twisting this little bit. We'll be taking most of them, but we'll be twisting this little bit. First start with lower bound. Okay, first start with lower bound. So initially what we'll be doing, first we'll be taking a low pointer and a high pointer. Okay. So this will be low, this will be our high. So low will be at 0, high will be at length of n minus 1, right? Then we'll be finding the middle node. So here what will be the middle node? Let's say this is our middle node. Okay. Let's say this is our middle node. Okay. Then what we'll do? We'll compare this array of 3 with target. So what is this target? Let's take target as 2 here. Okay, let's take target as 2 here. And we are finding lower bound. And what will be the answer? Answer will be 1, right? Answer will be the first index. So let's do it. How we can do that? First, we'll be finding the middle node. Okay. Then what we were doing? So if this error of m, this element is less than target, if this less than target, then we'll be searching at this right hand side, right? At the right hand side. Otherwise, if it is less than target element, then we'll be searching in the this side, right? So here what will happen? So error of m is 3 and target is 2. That means, and the array is sorted obviously, then we can ignore this part, right? Then what we'll do, we'll move our this high pointer from here to m minus 1, right? That we are doing. Okay, now this is happening. Okay, then let's calculate the m again. Let's calculate the m again. What will be the middle node here? So middle node will be, so this is basically, let's do that. So it will be 0 1 2 3 4 5 6, right? This is 6. Okay, then what will be the middle node? So 0 plus 6 by 2 equals to 3, right? So this will be our middle node. This will be our middle node. Now this is the thing here. So now middle node, now this middle node equals to target here. So previously what we were doing, if we find that error of m equals to target, then we are just returning true here, right? But this time what we'll do, even if we find that this middle element is target, now this could be our possible answer, right? This could be one possible answer. Okay, this could be our possible answer. Okay, so 3 could be our possible answer. Okay, but you can see 3 is not our actual answer should be 1, right? Actual answer should be 1. So 3, but 3 could be our one answer. We don't know in the left hand side is there any 2 or not, right? So when we find that this middle element equals to target, then what we'll do, in spite of returning anything true, what we gonna do, we sure that this could be our possible answer. Then we'll ignore this part. We'll be searching at this part because there may be possibilities that we will find 2 in this side again, right? There could be one possibility. If it is not, then it is there also, it is there already, right? So then what we'll do, we'll just move our high pointer from here to here in minus 1. Let's see. Okay, we have not stored 3 here, we have not stored 3 anywhere. Okay, so let's say we guess that in the left hand side we can find the 2 again here. Okay, we have moved to this side, so now our search space is this only. Search space is this only, 0 1 2, right? Now what is the middle will be 0 plus 2 by 2, right? Equals to 1. So this is our middle. Now again this middle element equals to target, right? Equals to target. Then what we'll do we return anything? No, right? We'll not return anything. Then what we'll do, we'll move our high pointer from here to m minus 1, right? Here to here. Okay, done. Okay, then high is here, Then high is here, low is here. What will be the mid? Mid will be this one. High is 0, middle is 0. So mid will be this one, right? Now tell me, is the middle. So middle is error of m is 1, right? So 1 is less than target, right? 1 is less than target. 1 is less than target. That means 2 couldn't be in the left hand side. 2 will be in the right hand side. So whatever element we have found that is less than our target element, that means we have to search in the right hand side, right? So what we'll do? What we'll do? So we'll move our left from here to here. So that will be our left. Now, in this time, so low is here, high is here, right? Now, if you see, low is greater than high, right? That means this condition is false. This condition is false. So, what will happen? This loop will stop. This loop will stop. And at last, whatever the low value, that will be our answer. What will be the low value? That will be our answer. Means what we have to do? We have to do a minor change. So what we have to do, just remove this one also. What we have to do, so if it is less than k, then yes. If it is less than k, then we have to search in the right hand side. If it is greater than, then you have to search in the left hand side. But if it is equal, let's say this one, if it is equal, in the middle equals to target, then we have to search in the left hand side, right? Then what will happen? We don't have to return anything. So we'll move our high to m minus 1, because we have to found lower bound, like, so what is the least position? And at last, whatever the low value, that will be our result. So at last we will be returning L. So this is the code. Very, very simple. Let's take another example. Let's say target equals to 10. That is not present here. Okay. And we are searching for lower bound. Okay. So 10 is not present here. Okay. So what will be the target? So what will be the lower bound here? So that will be the length of the array, right? So whatever the length of the array. So let's say, let's index it 0 1 2 3 4 5 6 7 8 9 10 11 13 14, right? 14. Okay. Then if the last index is 14, so for target 10, what will be the answer? What will be the answer? Expected answer would be 15, right? Expected answer would be 15. Okay. Let's see. Let's dry run for this one. Okay. Let's dry run for this one. Yeah. Okay. So let's say, let's take two pointer. First low here, high here. Okay. Let's take different color. So let's say this is low, and yeah, this is high. Okay. Now first thing we have to uh, find the middle node. So 0 plus 14, what will be the middle? Middle will be 7. Okay. This will be our middle. Let's take another color. Okay. This will be our mid value. Okay. Now what is the mid? Mid is 3, right? Mid is 3. Now what is the target? Target is 10, right? That is greater than 7, right? That means this portion we can ignore. We will be searching in this portion, right? We'll be searching in this portion. So then what we'll do? We'll move our low from here to here. Okay. Then again we'll be finding our mid. So mid will be 8 plus 14, 8 plus 14 by 2, right? So mid will be, so let's say, not 4, 8 plus 14 by 2 equals to 11, right? Equals to 11. So then mid will be here in this 11. Okay. Now let's see, what is this element? Element will be 5, right? Now target is 10. So target is 10, but middle element is 5. So where we have to go? We have to search again in the right hand side. Again in the right hand side. So again what we'll do? We'll move our left from here to here, right? Move our left from here to here. Okay. Then again we'll calculate our mid. We'll calculate our mid. So what will be the mid? Mid will be 12 plus 14 by 2. So 6 plus 7 equals to 13, right? So this will be our mid value. So what is this mid? Mid is 6. So 6 is less than target, right? Then what we have to do? We have to search in the right hand side. So what we'll do? We'll move our low from here to here, from here to here. right? And again we have to calculate mid. What will be the mid? Mid will be this one, mid will be this one, 14, right? Now what is the element at 14? At 14 it is 6 again. Okay, again 6, it is less than target, right? It is less than target. That means we have to search in the right hand side. So what we'll do, we'll move our low pointer from here to here, from here to here. So this will be basically 15. That is imaginary, right? That will be 15. That is imaginary. And low is exceeded the high value, right? Low is exceeded the high value. That means this loop is ended. This loop is ended. Now, whatever the low element, that will return here. That will return here. And what is the low value? Low value is 15, right? Low value is 15 here. So what is 14? Then what is the next element? It will be, next index would be 15, right? That is our answer. So here you can see we got our answer. So this is how lower bound works, right? Lower bound works. Now for upper bound, what we have to do? We have to do the same thing. We have to do the same thing, but this time let's say we have found a middle element here. Let's say we have found a middle element here, and let's say target equals to also 2. Now let's say we have find in the middle element at here. Okay, so in the lower bound, when we got the target equals to the middle element, what we are doing, we are moving our high pointer to here, right? We are, what we are doing, we are just making our high pointer to in the left hand side, because we have to find the lowest value. But for upper bound, we have to do just reverse. Whenever we found this element, we'll be this time shifting our low pointer to low equals to mid plus 1. We'll be doing low to mid plus 1. Okay, let's write the code here. First thing, okay. So what we'll be doing, will be, okay, if error of m is less than k, then just search in the right hand side. If it is less than k, sorry, if it is greater than k, that means we have to search uh, yeah, in the right hand side. Otherwise we have to, okay, if it is equal, then what we have to do, in spite of returning 2, will be move our low pointer to m plus 1, because we are finding the upper bound, right? The right hand side, rightmost element. And at last here also will be returning low. Let's dry run this. Let's dry run this. Let's remove this one. Okay, so what is this target? Target is 2. And what is our expected result? Let's see. Let's increase the font a little bit. Okay, so yeah, now it's fine. Okay, so let's index, let's give, put the indexes 0 1 2 3 4 5 13 14. Okay, right. Now what will be the upper bound for 2? For 2, answer would be the 6, right? The 6. So last occurrence of 2 is 5, index 5. Then if we want to insert a element that just greater than 2, would be index 6. So answer would be 6. Okay, let's see. Now let's take 2 pointers. One is low, this is low, and one is high. Okay, this is high. Okay, done. Now, okay, let's calculate mid. Mid will be 7. Okay, now is this 3? Now this 3 equals to target? No, right? No, right? No, right? That means we have to search in the left hand side. Okay, then what we'll do, we'll be moving our high from here to m minus 1, right? Here to m minus 1. Then what we'll do, again we have to find the mid. Again we have to find the mid. So what will be the mid? Mid will be, so 0 plus 6 by 2 equals to 3, right? So this will be our mid here. Okay, now what is this target? Target is 2. Now element is also 2. Now, right, element is also 2, target is also 2. Now what we'll be doing, in spite of returning anything, we'll be moving our left pointer from here to here. We're finding the lower bound, we are moving high pointer, but this time we'll be moving low pointer. Okay, so yeah, so let's say low pointer is here. Okay, then what we'll do, again we'll be calculating mid. Okay, so what will be mid? Mid will be here, right? Mid will be here. Now is this mid equals to target? Yes, right? Then what we'll do, again we'll be moving our low pointer from here to here. Okay, index 6. Okay, Now what we'll do, again we'll be calculating our mid. What will be mid? Mid will be also this 6, right? This will be our mid. Okay. Now what is the mid element? Mid element is 3, right? So 3 is greater than target, then we have to go to in the left hand side, right? Then what we'll do, we'll move our high pointer from here to here, right? From here to here. Yeah, from here to here. Now our low is here, high is here. So low is greater than high, will be stop. Will stop executing, right? And now what is our low? What is our low? What is our low? Low is at 6. Low is at 6. That will return. What is the answer? 6 here, right? So that's how we'll do this. Now let's go to our VS Code and write the code for this. Okay. Now let's take an array. So this is the same array we have gone through the example. So let's create a function. First, let's say create a function for lower bound. So lower bound, and it will take an array and a target element. Okay. Now what we'll do, we'll take a index low equals to 0, then high equals to, it will be length of the array -1, right? Then we'll run a while loop while low is less than equals to high. Do the operation. So first we'll be finding a middle node. Mid equals to, it will be low plus, sorry, low plus high minus low, float divided by 2. Then we'll run the condition if this error of m is less than this target. Okay. Then what we'll do, so if error of m is less than target, then we'll move our low pointer to m plus 1, right? If error of m is greater than target, so that means we have to search in the left hand side, right? So high will be m minus 1, right? Else what we are doing, we are returning true, right? But while we find lower bound, that means again we have to move our high pointer to m minus 1, right? M minus 1. And this thing we can't write directly. Like if error of m is less than 1, then make the tar so make the l to m plus 1. Otherwise we can remove this whole thing. We can remove this whole thing. Yeah, we can remove the, because we are doing the same thing here also. We are doing the same thing here also, so we can neglect this thing. Okay, let's remove this, and at last just return this low. Okay, return this low. So this is how we found lower bound. Okay, let's try this. First let's print, okay, let's take a variable, let's say lb equals to, let's call the lower bound function, pass the array and target element as, let's say, 2. Okay, now print this string, print a lower bound of, let's say, 2 is put lb. Okay, now let's run this. So you can see lower bound of 2 is 1, right? Index 1. So let's remove this one also. Yeah. Okay, now write this function for upper bound. So this time def upper bound. Okay, it will take array again, target, then let's take low equals to 0, then again a high equals to len of error -1, -1. Then again let's run a while loop while l less than equals to high. First find middle node, middle equals to low plus high minus low. Then write the condition if error of m is less than target, l equals to m plus 1, and l if error of m is greater than target, then what we'll doing, age equals to m minus 1, right? And in the else condition, what we are doing, we are returning the index, right? But this time we are returning basically true, but this time what we'll do, we'll move our low pointer to low equals to m plus 1, right? So this two condition we can merge here. So in spite of writing this, we can write like this, and here we can remove else, and here in spite of else is target, we can directly return else. Okay, so if it is less than or equals to target, then move our low pointer to m plus 1, and at last just return low. Okay, this will be our upper bound. Similarly, create a variable called ub and call this upper bound and put the same array and element 2. Okay, so do the same thing. So here in spite of upper bound, let's put, oh, okay, lower bound, upper bound here, and there lb in spite of lb, let's put upper bound. Okay, now let's clear this and run it. Okay, you can see lower bound of 2 is 1, and upper bound of 2 is 6. Now let's put different example. Let's say 12, that is not present, right? 12. Okay, what should be answer would be 15, right? Because 14 is the length of the array. So let's run it. So here you can see for lower bound is also it is 15, for upper bound also it is 15. Now I hope you have understood what is actually lower bound and what is upper bound. This is very important concept. Later we'll see how we can solve many questions using this upper bound and lower bound concept. So I hope you have understood, and that's it for today.